learning target 9 is just solving equations. It wasn't super long or like super difficult. I shouldn't put on the other quiz because those problems were long and really difficult. So learning target 9 is just solving equations. You guys know how to solve equations, and then we're going to use the unit circle to find the solutions, so it won't be that bad. Now, I gave on the note sheet a variety of different types of equations so that we knew how to solve them all. And the difference is the questions, like directions they're asking. So the first part says defines the solutions to the equations using principal values. And we've talked about principal values before with the unit circle, but just as a reminder, sine x and tangent x have principal values between negative 90 and 90. So if you look at the unit circle, then you can only look at this half of the unit circle for sine and tangent. And again, since we're doing negative 90 to 90, then this is negative 90 degrees, and this is negative 60 degrees, etc., etc. So just be careful of that, okay? And then for cosine, you're from 0 to 180, so the top half of the unit circle. So when we look at the unit circle for this first set of questions, then that's what we're looking. So it says solve each equation for principal values and express the solutions in degrees. I'm actually going to do B and C on your note sheet first just because they're a little bit simpler, and then we'll go back and do A. So for B, if we're solving the equation, this is just basic algebra. So we subtract 1 and divide by 2. So sine x equals negative 1/2. To solve for x, technically, I'm using the reciprocal. So I need to look at the unit circle and find where sine is negative 1/2. So on the unit circle, sine is negative 1/2 right here. It's also negative 1/2 right here, but we're using principal values, so we can't look to this side of the unit circle. We can only look between negative 90 and 90. Also, we can't use the 330 degrees that's on the unit circle. We need to use negative 30, since again the boundaries are negative 90 to 90. So x is negative 30 degrees. That's pretty much the premise for every single one of these questions. For the next one, we add the square root of 3. And we divide by 2. So cosine x equals the square root of 3 over 2. So again, we go to the unit circle, principal values though. We're looking for where cosine is the square root of 3 over 2. Cosine is the top half of the unit circle. So cosine is the square root of 3 over 2 at 30 degrees. I'm going to stop referencing the unit circle because you guys have one on your desk, but just so you know, that's what we're looking to find all of these solutions. Now on the last one for this page, we have sine x cosine x minus 1/2 cosine x, and there's a cosine x in both parts of the equation. And it's really tempting to divide cosine x out because that would make just, you have sine x minus 1/2 equals 0. But you know from algebra you can't just divide parts of the question out, divide variables out, because then you miss solutions. So in this case, we're going to have to factor the cosine x out. And so if you want to think of factoring as undistributing or however you think of it, we're just taking it out of each piece. In doing so, you have two factors that are set equal to 0, so you can use the zero product property to solve the equation. So you have cosine x equals 0 and sine x minus 1/2 equals 0. And if we solve this equation, sine x equals 1/2. So now we're just going to the unit circle to see where cosine x equals 0, again, principal values. So cosine x is 0 at 90 degrees, and sine x is 1/2 at 30 degrees. So you have two solutions there because you had two separate equations, two separate factors to solve. See, these aren't too bad. We're just going to keep going through this packet on your note sheet. got more examples, different types. So I threw in a bunch of different types of examples just so you kind of had an idea of what to try. All right, the next set, still just solving equations. These just say to solve them from 0 to 360. So this time we're not bounded by principal values, and we can look at the entire unit circle. So for the first one, we have sine x cotangent x, and we know that's kind of messy. We also should know enough about our trig identities to know that cotangent is cosine x over sine x. So I rewrite those. The sine x's cancel out. I have cosine x equals the square root of 3 over 2. And so now, if we go through this, I'm looking on the unit circle to find everywhere where cosine is the square root of 3 over 2. That happens at 30 degrees, and it happens at 330 degrees. So now I have two solutions because I'm looking at the entire unit circle. I'm not fixed within some certain boundaries. On the next one, again, we need to know some things about identities. I see a cosine 2x. That's a double angle identity, and I know that I should probably replace it. There's a sine squared x in the question. So if you go to, I'm going to go back to the double angle identities from the other day. I already have a sine squared x in the equation. I have three possibilities that I could change cosine 2x to. If I change it to cosine squared minus sine squared, now I have a cosine squared in the question and a sine squared in the question. So that won't help us because now we have two different functions. They wouldn't be able to factor anything out. It would just be complicated. Since there's already a sine squared in the question, it would be smart to use 1 minus 2 sine squared because then you just have one function involved in your equation. So I'm going to replace cosine 2x with 1 minus 2 sine squared. To solve the equation, then I end up getting all the like terms together. I'm going to add the sine squareds together. So I have 1 equals 3 sine squared x minus 2. So I need to get the constants together. So I have 3 equals 3 sine squared x. And then we divide by 3. We get 1 equals sine squared x. And to get rid of the square, we take the square root. Now be very careful. You guys all know that if you take a square root, you can get a positive or a negative answer. Most of the time, the negative doesn't matter. In this case, it does matter because there's positives and negatives on the unit circle. So the square root of 1 is positive and negative 1. So just solve for x. We look at the unit circle. And where is sine 1? Sine is 1 at 90 degrees. And sine is negative 1 at 270 degrees. So different things you might have to try to solve. Both of these, you had to use your identities and replace in order to get the equation to work. On the next set, same thing, just wants the answer from 0 to 2 pi. That means it wants the answer in radians. For the first one, we add 1 and divide by 3. We have to take the square root. So we get tangent x equals 1 over the square root of 3, because the square root of 1 is just 1. And it's positive or negative. This is also the same as the square root of 3 over 3. Now, tangent x on the unit circle is y over x, or sine over cosine. So if you just look at the first quadrant, tangent isn't going to be the square root of 3 at 0 or at 90 because you get 0 and undefined there. Tangent isn't going to be the square root of 3 over 3 at 45 degrees because you get 1, because you have something divided by itself. So your two options are 30 degrees, or pi over 6, we want radians this time, or pi over 3, which is 60 degrees. Pi over 6, you would take y, 1/2, divided by the square root of 3 over 2. So you multiply by the reciprocal. At pi over 3, you would have the opposite, the square root of 3 over 2 divided by a half, so times 2 over 1. And so it looks like this is where the correct answer is at pi over 6. So I know that one of the answers or solutions to this equation is pi over 6. But I have to identify that for every quadrant because it's going to happen again in the second quadrant, and the third, and the fourth, because we're looking for everywhere it's positive or negative. So what we need to do is just look at the coordinate at pi over 6. You have the square root of 3 over 2, comma 1/2. This coordinate is going to be repeated in each quadrant just with different signs. So in quadrant 2, that happens at 5 pi over 6. At quadrant 3, that happens at 7 pi over 6. And in quadrant 4, that happens at 11 pi over 6. Right? So you just need to kind of narrow your focus, figure out what coordinate works to get your solution for tangent, and then go from there. On this next one, again, I've got a cosine squared and a sine squared, and that's kind of messy. We know there's an identity. Cosine squared x plus sine squared x equals 1. And we can rewrite those identities. So anywhere I see a sine squared, I know I can replace that with a 1 minus cosine squared. So I'm going to do that in this question. That way I have all cosines. Again, if I have two functions, it makes it hard to solve unless you factor something out. So next, we're going to go through and combine like terms. So I'm going to subtract the 1 and add the cosine squared x. So I have combined like terms. I have 2 cosine squared x minus cosine x. 1 plus negative 1 is 0. Then we move everything so it equals 0. So now I've eliminated that 1, and so now it's not really a trinomial that I need to factor. There's just 2 terms. Again, I can't add cosine and divide a cosine out because I'll lose parts of my solution. So just like some of the other problems, we need to factor cosine out. So we get 2 cosine x minus 1. So cosine x equals 0. 2 cosine x minus 1 equals 0. So that's cosine x equals 1/2. So again, we're looking at the same thing, looking at the unit circle to find our solutions. This time they're just in radians. So cosine x is 0 at pi over 2 and 3 pi over 2. And cosine x is 1/2 at pi over 3 and 5 pi over 3. And just using the unit circle to find the solution. So the first set was based on principal values, and these last 2 sets were based on 1 full revolution on the circle, 0 to 360 or 0 to 2 pi degrees or radians. And so I've got one more set of questions, and these say for all real values of x. That just means that you want to include every single possible angle that's coterminal to any of the ones on the unit circle. So that's infinite solutions because it goes around the unit circle over and over and over again. So if you're using degrees, you tack on a plus 360k. If you're using radians, you tack on a plus 2 pi k to show that you're going around the circle infinite times. So the first example, I see a sine 2x. So you use your identity. Sine 2x is 2 sine theta cosine theta. So 2 sine x cosine x minus cosine x equals 0. Again, just like most of other questions we've done, we have to factor out a cosine. So 2 sine x minus 1. So cosine x equals 0. 2 sine x minus 1 equals 0. So sine x equals 1/2. And so now we're just trying to find those solutions in the unit circle. So cosine x is 0 at 90 degrees and at 270 degrees. But since we're looking for all real values, we tack on a 360K. An equivalent statement would just be x equals 90 plus 180K, since those are repeating every half of the circle. So you can have both of these, 90 and 270 plus 360K, or 90 plus 180K. Both of those work. For sine x equals a half, you have 30 degrees and 150 degrees. And you put plus 360K after each. And again, that's just indicating there's an infinite number of coterminal angles that could work. All right, 2 more questions. And these 2 are both trinomials that you have to factor, like a quadratic equation. So you've got tangent squared x plus 2 tangent x plus 1. That's like having x squared plus 2x plus 1. So I'm looking for 2 numbers I can multiply to get 1 that add to be 2. So that's 1 and 1. Because 1 times 1 is 1, and 1 plus 1 is 2. So I have 2 factors that would set equal to 0, but they're both identical. So I don't need to use both of them. I just need one. So tangent x plus 1 equals 0. So tangent x equals negative 1. So tangent x is negative 1 on the unit circle at 135 degrees and at 315 degrees. So again, plus 360K. Or, again, in this case, they're repeating every half of the circle, 1/2 rotation. So you could write x equals 135 plus 180K. Doesn't hurt to write them separately, though. I've got one more example. So this one says it's equal to negative 2, but you have a quadratic, so you can't set things equal to negative 2 if you're going to solve anything. You need to rewrite it so it equals 0. So it's just x squared plus 3x plus 2 if you need to look at it that way. You can multiply to get 2 that add up to be 3. And so that's 1 and 2. So cosine x plus 1 equals 0. So cosine x equals negative 1. And that happens at 180 degrees. And then cosine x plus 2 equals 0. If you think about the graph of cosine, it was a wave, and it went up to 1 and down to negative 1. So cosine x can't equal negative 2. That would be undefined. We don't have any solutions for that. It doesn't exist. So we only have this one solution after all of that work. So Elementary 9 is just solving equations. Again, there's multiple ways we might need to solve the equations, but we always go back to the unit circle to find the answers.